All right. Welcome, everyone, and thank you so much for joining us today. Then I'm going to hand over to our speaker this morning, Jostein. Whenever you're ready, you can bring up your slides.
Okay, thank you so much for inviting me to this webinars. My name is Jostein Iversen. I work in Grieg Seafood as a sustainability advisor. I have a technical background in marine engineering from NTNU and has worked at Grieg Seafood for a couple of years now. I would say I mainly work with sustainability issues related to climate and also plastic, which are like two main topics. I will give you a brief introduction to how we work with sustainability, but first I would just like to give you a short introduction to the company itself. So Grieg Seafood, we are a global company. We are working with aquaculture, production of Atlantic salmon. We are I think we are the 8th biggest salmon producer in the world today. It's changing a bit between 6th and 7th and 8th, but 8th today, I think. We are about 750 passionate employees, and we're producing 90,000 tons of salmon a year. And that's a lot of meals if you're not aware of that. So that's a lot of protein being produced, more or less. So we are situated in Norway, where our main office is. I live and sit in Bergen, where we are. We also have 2 production regions in Norway. In the north, we have Finnmark, which is we actually have the northernmost farming in the world at Vannfjorden, at the North Cape. It's quite close to the edge of the continent. And we also have production in Rogaland in the south, where we also produce Atlantic salmon. In Canada, we are situated both on the west and east coast. In British Columbia, we have produced for several years. But in Newfoundland, we have recently started our new production and are initiating this. We are harvesting the fish for the first time this year at the autumn. So that's quite exciting for us in new water. So just briefly touching protein production as a topic. Why should we produce Atlantic salmon, and why should we produce it with aquaculture? So the thing with Atlantic or farmed salmon is that it is probably the most efficient house animal that we have today. It is more or less, the feed you put into the fish is almost equal to the amount of meat you get out from the fish. It is a very high edible yield, and it also have a quite low carbon footprint compared to other production animals. So the numbers here varies, of course, between regions and European and American sites, but these are some numbers that you can use as a reference. If you want to source for these numbers, I would recommend you to go into the website Global Salmon Initiative, where we annually report on the sustainability of aquaculture salmon. So I would just like to mention the challenges we are facing. We are producing proteins in the commons. We are using fjords and water systems that are available. And it's very important for us to ensure coexistence with nature and other species. One of the most important topic for us is ensuring that wild salmon is being taken care of. There are some connections between farming Atlantic salmon and that diseases from our production may be transferred to the wild salmon. We also have lice, which is a parasite that is coming with the water, and when it hits the pens, it might be transferred to the wild salmon, and that's why we have a lot of measures, and we do a lot of effort to try to avoid this as much as possible. We also have we are not satisfied with the fish health and welfare that we are seeing today. There's a lot of challenges related to, for example, vaccines. We are producing a lot of individuals, a lot of fish in each pen. So when we are situated with a disease, it can be quite a big challenge for us. So that's why we have used a lot of funding on. We have funded a lot of research on vaccines, which has made, for example, the antibiotic use in the 1990s in Norway has almost gone to zero now because of developed vaccines. And this is like technology that we are trying to transport to other regions. But there is, of course, differences between the regions because you have different environment and different bacteria. So you have to develop vaccines for each region. When it comes to the CO2 footprint of the salmon, I would say that 80 to 90% is more or less coming from the feed ingredients that we are purchasing. Today we're using approximately 20% of the feed comes from Brazilian soy, where we are seeing some high carbon footprints. It is important to note that we in Norway and in GSI, Global Salmon Initiative, have been buying deforestation-free certified soy products for many years. And we've also been a big adversary for ending soy deforestation in Brazil. If you have any questions about that, I would love to answer you, but I'll just continue. Cutting carbon emissions is important for us. That's not the topic today, but recycling resources is something that I work a lot with, especially the plastic issue. And of course, promoting human rights, where we have a lot of policies and code of conduct, which we are using a lot of effort on trying to uphold a high standard for our supply chain. Okay, so how do we work with sustainability in Grieg Seafood? So we have separated it into different pillars with different topics, which are aligned to the United Nations Sustainable Development Goals. As you can see in the third pillar here, sustainable food, we have situated plastic pollution as one of the main topics. And it's also my responsibility to work with this. Just to briefly address the carbon emissions, which of course is a huge challenge for companies today, I would just like to refer to the Paris Agreement, where Grieg Seafood has set targets that are in line with the Paris Agreement. So we are today aiming for 35% reduction of our greenhouse gas emissions from scope 1, 2, and 3, and being 100% reduced in 2050. These targets have been approved by the Science Based Targets Initiative, which is a widely known assurance company that are working to ensure that private companies are setting targets that actually are in line with the Paris Agreement. So that's that we've had science-based targets for 3 years now, since 2020. Okay, so plastic emissions or ocean plastics. So how are we working with this as a private corporation? So first of all, we have released a public ocean plastic policy. You can find this online on our website, where we have put all our principles on how we are going to work with this issue, also set targets and a responsibility. So there's a lot of text here, so I'm not going to go into all of this, but if you're interested in, and this is something that I recommend you as a group, for a student group, that you should check out the plastic policies for the corporations that you are working with and ensuring that they are actually following up on it. This is something that we are interested in stakeholder feedback on this. So please feel free to just send us messages on this. This is something that I'm working quite much with. And the reason for this is that we are producing salmon in one of the most beautiful, pristine nature areas in the world. So this picture here is from Øksfjord in Finnmark. The water here is probably 4 degrees cold, so it's quite cold here, but we are producing in quite beautiful areas. And it's really important for us that if there is a bad weather and there is a storm, for example, and we have plastic that is going to be ending in the ocean, it is really important for us to pick up this as quickly as possible. That's why we are doing several ocean cleanups in the related areas where we operate all of our farms. What we are seeing in modern aquaculture today is that we are going more and more into plastic equipment. Mostly all of the aquaculture equipment is being produced in plastic today. And the reason for this is that plastic is a fantastic material to work with, but of course it has its challenges. When it comes to this picture, I've taken this picture from one of our production barges. So I'm standing on the barge now. And what you're seeing is the white feeding pipes that are going out to the pens. These white feeding pipes one of them could be approximately 600 meters long, and we have more or less 8 of them on each site. In Norway, there is 1,000 sites being operated every day. So you can imagine the numbers here. Just to show you what we have done, when it comes to the use of these pipes and plastic recycling, we have set bins on our boats to be able to collect ropes and, of course, other plastic materials. We have separated today. We are separating the types of waste that we are collecting. At the land bases where we are collecting all of the used feed pipes, we are chopping the feed pipes up and sending them to a shredding service. As you can see on this left bag here, I have a laser pointer here. These are shredded feed pipes that are going into a mechanical recycling center and coming out as 100% recycled granulates, which are then being used further in industrial applications. It's really important for us to have a transparent and open information in relation to how this is being operated. So that's why we are documenting this by requiring life cycle assessments from our supply chain, waste supply chain. This is quite interesting because you're seeing that there is a huge potential when it comes to CO2 saving CO2 equivalents here. What we are seeing is that if we're using these granulates back into the products that we're buying, we are reducing the emissions from procured plastic by 80%, and that's a lot. It's important to note that when you're collecting waste or used equipment in the aquaculture industry, it doesn't always look that beautiful. It has a lot of growth, like macroalgae, mussels. There is a lot of salt. Sometimes you have feed spill, like fat or like oils that come from the feed. That is so much of the equipment is really dirty when we are collecting it. So what we are doing is that we are collecting all of our plastic to the land bases, then we are manually separating it, and then the waste companies are coming and collecting it. And this is quite a huge task for us. It's something that we use a lot of time and resources on. So it's not that this is coming by itself. This is something that we have to allocate time. We have to educate the managers on you can't just produce salmon. You also have to make sure that our aquaculture technicians have time to do this work. So that's quite a big effort. What we have seen is that when it comes to plastic management and plastic handling, there's a lot of questions being raised. But why am I doing this is the typical question. Isn't it just going to be sent to landfills? Isn't it just going to be sent to Germany for example, burning? But what we're seeing is that more or less all of the plastic, the high quality plastic that we're using in the aquaculture industry today, has a high degree of recyclability. So that's why we're using, together with NTNU and Bellona, we have received funding to develop a massive open online course in plastic handling for aquaculture. The reason we are doing this is that we are hoping that it will increase our collection rate of plastic, and also increasing how you separate the plastic. It's important that we know the use and value of the waste, and to know the use and value of the waste, you have to see the potential use of it. And that's something that this course is probably going to address for many people. So this is going to be developed now and being published in the summer of 2023 this year. So I'm looking really forward to sharing this with you all. And the reason, one of the biggest reasons for this is that this picture is taken at one of the waste handler sites we have. What we are seeing is that if we don't have a good resource, a good separated waste from the aquaculture production, the waste is being intermingled and then being more or less impossible to separate, reducing the recyclability. So this is really important to understand, that if you want to have a high recyclability, you have to use a lot of effort as early in the waste supply chain as possible. The last years, I spent a lot of time looking into and seeing the sites where we are collecting the waste. Here are some pictures. To the right here, you see the large floaters that are being used in the pens. So these are the floating infrastructure that are making sure the floatability of the pens. The reason that these pipes float is that it is expanded polystyrene or styrofoam, more or less, inside of the HDPE, the plastic. And the challenge here is, of course, that when you're going to recycle this is two different products, two different materials that needs to be handled differently. So when you're producing the equipment, it's also really important to have a good discussion with the designers and the suppliers of the equipment to how can we reduce or how can we improve, the recyclability of the equipment after use. So what we have done now is that we have told them about this problem, and now they are producing actually floaters without styrofoam inside. They are just encapsulating air and using that as a floaters. It's cheaper for them, and it's also increasing the recyclability of the product. So it's a win-win situation, but it hasn't been addressed before this has become a problem. So that's more or less some of the funny sides, but also the funny sides sometimes also have a huge consequence on the industry. We're also shredding a lot of polystyrene, and you're seeing here that the big bags are separated. You see the orange text on the big bags, which are saying that if it's HDPE or PVC or the different types of plastic. So there is a huge market for this today, and these are being sent everywhere in the world. We're hoping that it's being utilized locally, but there is not a good enough infrastructure for this today. But maybe in 2030, we will have a higher degree of, or what we call like smaller circles in terms of circular economy. There's a huge potential when it comes to the value of waste being utilized locally. So being able to understand where to build the best circular economy hubs, like collection centers of waste, is probably one of the big issues towards 2050 now. So challenge for you students. For 2 weeks ago, I went to Slovenia, where I visited the world's biggest producer of EcoNyl, which is the 100% recycled nylon product. What you're seeing here is one of our nets that are being used to to have when we are producing, you have the floating pen, and then you have the nets going approximately 30 meters down. To just put this in context, one net could be 160 meters in circumference and 30 to 40 meter deep. So there's a lot of plastic, a lot of nylon that is being used. The weight of this one is 1,376 kilos. And we are also using some different insulating materials like copper, for example, to protect the nets from growth, like marine growth, like algae growth. And that's also a challenge when it comes to recycling. Just recently, this Aquafield, which is the factory here, was able to have to take a patent on the recyclability of copper pens. What's quite interesting as well is that the supplier, or the waste supplier here, which is Nofir, they have a full supply chain monitoring, where they have, as you can see here, there's a QR code which I scan with my mobile camera. And when I did that, I get all the information about the pen, where it came from in Norway, how long it's been in sea, the amount of the weight, the amount of water, humidity, the amount of impregnation, copper, etc. This is really important to ensure recyclability, that we know the data, the usage data, the more or less the material data from the production of the net. And all of this data needs to be maintained throughout the whole circular supply chain. So that's one big challenge that we're seeing today, being able to aggregate the right amount of data and making this transparent between the different participants in this supply chain. On this page, the net is being stored at the warehouse, where it is going further for processing. It is then being mechanically shredded, and here you can see the mechanically shredded and dried nylon. This is then being put into a chemical process where it's being chemically broken down, like with depolymerization techniques, being broken down into its original polymerization chains. And then it's possible to polymerize it into the products you want, so nylon. This eco-nylon product is actually being used by more than 2,500 manufacturers today. Adidas are producing swimwear and training gear in this. Gucci, Prada is using it. But what we as an aquaculture industry is interested in is not that this is going to fashion or textile production. We want it back into our nets. So right now we're working on trying to establish this as a closed circular loop. So you're producing nets from recycled nets, you're using them, shredding them, depolymerization, polymerization, and then they're going back into the nets that we are buying. So that's a really interesting project. We have had success with this in other products previously. So, but when it comes to nets, this is a quite huge challenge, as it is it has a lot of different parameters that need to be right. The material certificate here is quite high, more or less. Yeah, that's more or less the slides I had. I see I have 5 minutes left, so I hope there have been some questions. If not, it's going to be an early coffee on me.
I don't see any questions that have come through yet. So if anyone does have any, please send those through. But in the meantime, Jostein, thank you so much. It was really great to hear a good overview of the system and how it works. And it's really encouraging to hear the stories of how, for example, the pipes used in the pens, how those have been sort of modified to be more sustainable, and the circularity of the nets. It's really interesting to hear. I see Sure. I see there's a question that's come through here that says, it's great to see your efforts to reduce plastic waste. Thank you for sharing. Do you mark any of your nets or other gear?
Yeah, that's something that we have stated as a principle in an ocean plastic policy. So all of our equipment or plastic equipment, it has been marked with, we have the regional name and also like a phone number that can be contacted, especially if it's large equipment that are being lost to sea. So it's important to understand that we have like, we know that we are producing some ocean plastic waste each year we are losing equipment to the sea. We're trying to collect this and we're trying to mitigate, like if it's being found, we want to take responsibility for it, and that's why we're marking it. So that's something that that we have done for several years. Just a small thing as well, you can't mark, we use a lot of rope in the industry, but you can't mark the ropes. So what we have done is actually we have developed a totally own rope that is only Greek Seafood are using, which is own colored pallet, and it's also like a thread inside that is has a small marking on it. So it's like a protected inside the rope. So that's some of the challenges that we are doing. It's so when people are going at the shores and they are seeing ropes, it should be easy for them to say that this comes from a Greek Seafood production.
Okay. And I know earlier on you mentioned some of the ocean cleanups you were doing. Were those specifically for gear that has gone missing perhaps during a storm or things like that? Or was it for sort of all sort of plastic washing up?
We do it as a service, more or less, for all plastic. So we collect all the plastic we see. We have, since we are covering a lot of area with our farm, like if you have like a fjord in Norway, we are like following the fjord with a boat and on land all the way around where there's like a high risk of our equipment to being deposited. And also if we are finding other waste, we are collecting this as well and delivering to recycling or the waste management.
Okay. Wonderful. I see there are a few more questions that have come through in the chat that says, what happens to the copper that the nets are coated with in the ocean, and do they interact with the water ecosystems?
A really good question. And yes, it does. What we are seeing is that like the copper impregnation is helping us to produce. If we don't have the copper impregnation, more or less the algae will grow and the net will become totally dense, and then we will not have any oxygen or the water being transported in, and the fish will suffocate. So that's a big challenge for us. So what we have done is that we have seen other type of or we have developed other types of impregnation, but they are not as effective as copper because copper is a toxin for the environment. So it's not, there is no growth. The challenge with copper is that it's quite heavy, so it's going to be deposited on the seabed or the sea fauna. And what we are seeing is that the more we are producing, the more of the copper goes to the seabed, and this accumulates, right? When it comes to a high enough degree, you won't have any marine animals being able to live there. So that's a huge challenge. And when it comes to the Aquaculture Stewardship Council certificate, the HSC, there are like limits of how much copper that can be in the seabed before you have to change impregnation technique. So there's a lot of innovation on this today, but we don't have, I won't say we have a really good solution on it. The only thing is that in the water, there is copper being deposited from rivers, and like copper is not it's not a chemical, it's a elementary elements. So it's not like unusual to find copper in the fjords where we're operating. So we have, when it comes to like the risk assessment being done by the research, like the Marine Research Institute in Norway, they don't see the copper defouling in the fjords as environmental risk, but the copper depositing on the fauna is an environmental risk. So this is something that is being strictly monitored, and if we are seeing that it's being deposited, we have to stop with the copper use.
Okay. Very, very interesting. Can you elaborate a little bit more on how it's incorporated into the net? Is it actually wound? Is it a separate entity, or is it part of the manufacturing of the nylon nets includes the copper deposition?
I know you're talking about like aquaculture innovation here. Both, it depends. So you have you also have like a small copper wire that are being intertwined in the copper net. That's one product. You have copper that are being dipped in like liquid copper bath, and when you take it up, you're seeing the copper is like defouling. When we're transporting this, it's not a product that you would like to be in human contact with. So it's not it's not like a good product in terms of that, I would say. We have a lot of good cleaning solutions for it when the nets are being taken for material recycling, and of course the nets are being what's called like
treated
and maintained. There is good solution for this today, but of course you should avoid being in contact with copper. That's not a
Okay, very interesting as well that, as you say, it's sort of the right level of the right level of not allowing sort of organic life to interact, since that's slightly its purpose in the net.
As you can see on this net, it has been cleaned. So when I'm reading the material certificate here, I can see how much copper that is being inside of the net today. When the net is being used in the production, it is more or less like brownish. So it's quite copper filled, I would say.
Okay. Then I see there is a comment saying, very interesting talk. Good to see the aquaculture industry is taking strides to become more sustainable. And then we have a question that says, do you have more insights on how the certification in Brazil regarding the deforestation freeness is established?
So we have like 2 certificates today that are being available. The Pro Terra and Roundtable of Responsible Soy. So we have a clear requirement for feed producers that our feed is only sourced from Pro Terra or Roundtable Responsible of Soy. These certification schemes they have like their whole set of criteria and annual reviews, revisions of farmers, the soy protein concentrate producers, and the grocers and everything. So it's not that when it comes to the transparency of the feed products or the raw materials used in the feed products that we have, there is a huge challenge in the whole industry today, not only salmon aquaculture, but the whole feed industry. We have worked quite effortlessly on this in several years, trying to establish good, more or less on the climate side, good carbon data on the different sources of, for example, soy products that we are sourcing. But we're seeing that it's not like aquaculture industry is not a big player in this business. We are, I would say, I remember some data back from 2018. Less than 1% of all the soy protein concentrate that is being used is being bought by aquaculture industry today. So I think in Norway we use more or less 800 to 1,000 tons of soy today. And when we are like saying that we are not interested in this and this and this, we have had a lot of challenges being listened to. But what we have seen is that being like the guy who is picking them on the shoulders year after year has had a huge success. So back in 2020, we actually were able to like what's called like we had three main suppliers of soy protein concentrate: CJ Impoka and Koramaru, and one other. I don't remember the third name. They are like one of the big players in this soy protein concentrate production. And we said to them that they were not allowed to sell any other products than deforestation-free certificated products, because they were like separating. They were selling to aquaculture industry this good product, and then they were selling bad products where they didn't know if the soy came from deforested products or not. But we were able to say to them that you have to set a deadline from this date. You are not being able, and they actually signed this and have done this since 2020, and that has a huge impact on the other industries. Not only salmon production, but pork and chicken, and also cow production or steak or beef production. I mean, so that's something that like, but by being the annoying environmentalist, we're actually seeing some push being done globally, and that's something that we are actually really proud of today.
That definitely sounds like something to be proud of, and very encouraging and incredible that you have that sort of sway with them, that you can encourage the deforestation-free soy across the board. Sorry. Yeah, so that's wonderful to hear. I see we have another question that says, thank you for your talk. Can you tell us about the water quality monitoring that your farms do, particularly from introducing feed into the water and waste from the salmon?
Yeah, really good question. So we know today that if we produce too hard on a farm, we will overload the fauna and the system, the fjord system or the water system. So what we are doing today is that we have environmental what is called like we're doing like environmental tests prior to production. During peak production, where we produce our maximum amount, or like the maximum amount of feed is being used, and we also have an environmental survey after production, and also there has been done like environmental hydro studies on where does the waste, where does the water go, and where does all of the water in the fjord system being collected, and we also have an environmental survey there. So we are not allowed to, especially in Norway, we are not allowed to produce if the amount of fish feces or sludge and fish feed is too high, because what you're seeing is that it accumulates, and when you have fish poop, it depletes all the oxygen. It produces hydrogen dioxide, which is hydrogen sulfide. I mean, which is a toxin which also kills the species around. So that's why this is not allowed. So if we're having an overload production, we are being regulated that we are not allowed to produce in, let's say, a year or something, and then they are doing a new survey. And what we are seeing then is that if we had this overload, that the seabed has restored itself. So then we're getting issued reissued a new production license. I think that as I mentioned previously, there was a risk report being done by the Marine Institutes in Norway, and they are monitoring these reports every year. And what we're seeing is that above 90% of all farms have a good or very good fish feces footprint. So that's an important mark to have with you. But of course, there is some challenges. There are some sites that are not as good to produce on than others. So what we want is to move those sites into better hydrodynamic areas where the fish feces is being transported into the ocean system and being taken care of by the environment. This is what, when we have agriculture, for example, when you are with the fish, the feces from agriculture is going to the rivers and out in the fjord systems, and that's what we want. That's part of the nitrogen supply chain, the environmental nitrogen circle.
Okay. And then I see we have one more question. I think we may need to make this the last one. It says, is the industry doing any surveys on the loss of microplastics from the aquaculture gear and plastic accounting to document any loss of gear?
Yeah, that's a really good question. When it comes to the microplastic, I won't say that we have a good solution on that today. We are involved in a lot of research, and there is a lot of efforts being done on like monitoring how much from like feed pipes, how much waste is or like microplastic is being deposited. There is some projects going on now that we are following up quite. I was actually attending the North Atlantic Microplastic Center last autumn to see the recent studies on this, but it hasn't given us any like practical insights on how to operate. So what we have done, an example for the plastic feed pipes, is that we have addressed this issue with our supplier, and they have told us that they have produced a softer pipe, which they are seeing that has a higher degree of wear. So then they changed the formulation of the plastic to a harder pipe, which actually has a lower wear amount. So what we're seeing is that by discussing and talking with the different stakeholders in the industry, we are able to reduce the amount of microplastic. But when it comes to measuring this, we don't have any good tools today, unfortunately. So it's more or less that we have to address the issue on each issue separately. When it comes to material accounting and plastic accounting as well, we are working with this. We are collecting waste reports from our waste suppliers, and we have quite, I would say, more or less full control of the aquaculture plastic equipment that we're using. Feed pipes, ropes, the floating pans, the nets, as you're seeing here, the picture of Nofir, we have full accountability on. But it's of course some challenges to understand, we don't know fully if everything goes to recycling or incineration or landfills. We know that a lot of our plastic in Canada goes to landfill, and we're trying we have raised this question locally with the waste handlers, but they're not interested in sending this to North America for recycling because the costs are too high. So then they're landing the cost on us, and we're trying to handle this so as we are set in the ocean plastic policy that we don't want a target is that no plastic is going to landfill by 2025. But this implies that either you have to build infrastructure in Newfoundland in British Columbia that can handle plastic recycling, and there is no non-project like this today, or you have to transport it to North America, which of course has a higher cost and also a high CO2 footprint from the transportation. So these are the challenges we are working with today. I just would like to one point when it comes to the material accounting, we are trying also to see how much plastic are we buying each year, like how much rope, how much gear, and what type of plastic. This is something that is quite challenging. We get a lot of good information from our big suppliers, but not from everyone. So you have like the puzzle is not complete, more or less. So this is something that I'm working with now, actually. We are publishing our annual report in March, and this is a topic that we will cover there if you're interested for 2022.
Okay. Wonderful. I see it is just after 12, but thank you so much, Jostein, for joining. Carl, I do see that your hand is raised. I'm not sure if you want to unmute and comment, but thank you so much for joining us, Jostein. It's very encouraging to hear all the progress that's being made and the strides that you're taking to make sure that all of the materials that you work with are responsibly sourced and have an end of life solution. So it's very inspiring, and just as a I'm glad. Yeah, it's really great to hear. And just as a sort of closing comment, are there any sort of other, aside from the ones you mentioned in Canada, are there any upcoming items that you're hoping to address in terms of a sustainability angle? I know you mentioned the pipes that are used in the pens and the polystyrene there. Is there a next?
For the guys who are familiar with aquaculture industry, I haven't addressed the fish cases or the fish boxes that are being transported to market. So that's like the big elephant in the room. This is something that we don't have a good solution to today, but we are working with the challenge. So every year there is styrofoam fish boxes that the fish is being put into and sent to market. And like the big suppliers, they have a good overview of the products. But if we are sending small batches to countries that don't have good recycling infrastructure, we know that this is going to landfills and incineration, and often sometimes we have seen issues it ending up in rivers in Sri Lanka or Indonesia, and that's of course a huge problem that we are aware of and working with, but we don't see any like obvious solutions to this today. The biggest, I think we have to address this more or less as in the soy issue, where we have to get every participant in the supply chain in line with the policies more or less. And that's actually what we're seeing as the best tool for us working with environmental claims, is that we have to work with this, we have to only buy and only use the suppliers that are in line with our business conduct. And this is something that we are more and more taking care of in our code of conduct, which is a document that we are supplying saying that these are our criteria. If you want to work with us, you can't, you have to be in line with this. And human rights, corruption, trafficking, labor, like child labor, all of these issues are being addressed, and it's a huge challenge to monitor this correctly.
Okay. It definitely sounds like a big task, but given the success you've had on a number of other challenges, I think we're eagerly awaiting to see how that's resolved. Thank you so much, everyone, for joining today, and thank you, Jostein, for taking the time to share with us this morning. I'm sure you're quite busy, so we really appreciate the time that you took to share this with us, and it's wonderful to hear the sustainable solutions that are being discovered in aquaculture within the industry. So thank you, everyone, and please note that the registration link is available on the Sustainable Seas Trust YouTube page to join for the following webinars in our series, and we hope to see you there as well. And then the recording for this session will be available on the Sustainable Seas Trust YouTube page by the end of the week, if not today. And we hope to see you all next week. Thank you again for joining, and thank you, Jostein. Truly, it was great to hear. Great to hear about all the strides that you're making for sustainability there.
Thank you, Tara, for the invitation.
Thanks, everyone. Enjoy the rest of your Wednesday, and hope to see you next week. Bye-bye.
Bye-bye.